How are you? Cold. It is kind of a chilly day today. I agree with you. All right, so last time we were together, we were working with right triangles. We were talking about the geometric mean, which was that square root of things multiplied together. Today, we're going to fill in something that was a spoiler alert to you a few weeks ago, which was the Pythagorean Theorem. That a squared plus b squared equals c squared thing. Here's what it actually says, okay? The theorem isn't a squared plus b squared equals c squared. The Pythagorean theorem says that if you have a right triangle, then the sum of the squares of the lengths of the legs, that is, take the legs of your right triangle, this one and this one, multiply each of them to each other, so a times a, b times b, add that together, and your answer will always be equal to whatever this side is, the hypotenuse, after you square it. Okay? And so that's what the a squared plus b squared equals c squared thing is talking about. You have to have a right triangle to make that work. And once you have that right triangle, it's always going to be this setup. Now the neat thing is that anytime you have this setup, and they're whole numbers, you already noticed that when we've done these a couple times, some of them aren't like you get this weird decimal thing happening and it's like, ugh. Well, if they are actual whole numbers and they satisfy this equation, a squared plus b squared equals c squared, the Pythagorean theorem equation, then those three numbers form something called a Pythagorean triple. Right? Now the thing to know about the Pythagorean triple is that the sides of a right triangle that are formed by the Pythagorean triple are always going to be in some ratio of that triple. The most common triple that you'll see, ACT, TSI, is going to be the 3, 4, 5, or some multiple thereof. Which means if I take each of these three numbers and I multiply it by something, I'm going to get three different numbers. So if I multiply each of these by 2, I'm going to get 6, 8, and 10. If I multiply these by 10, I'm going to get 30, 40, 50. If I multiply them by 5, I'm going to get 15, 20, 25. You're always going to see those combinations if it's a 3, 4, 5 right triangle. Now, the good news for you is a couple of things. First off, that the Pythagorean triples never change. And in fact, you could go onto Google and you could type in Pythagorean triples and they give you hundreds of them. I'm not asking you to memorize any of them because why when you have Google in real life, right? So what I'm asking is that in your, whoa, let me close that door. They're getting very rowdy outside. They're having a lot of fun in that classroom. I try to have that much fun here with you guys. Sometimes I succeed, sometimes I fail. Sorry. What I'm asking from you guys on the Pythagorean triples is you can have either this chart in your notes or there should be a chart very similar to this one in your textbook, which you'll be allowed to have access to. That's okay? Is that you have these near at hand so that way you can use them to help you calculate stuff. Okay? I'm going to show you, let's skip down to 5, 6, and 7 at the bottom of the page. I'm going to bend my notes up so that way 5, 6, and 7 are first. All right, so let's do 5, 6, and 7 where we're using the Pythagorean triple, and then we'll go back to 1, 2, and 3 and remind ourselves how to use the Pythagorean theorem. Okay? All right, so here's our Pythagorean triple. Number 5 says, I have a right triangle. Which side is my hypotenuse? The 17, because that's the side across from the right angle, which means these other two sides are my leg lengths. So what I'm going to do is I'm going to look in my Pythagorean triples chart, and I'm going to look for one where the largest number is 17, because the largest number is always your hypotenuse.
15.
Here it is. One of my legs is 8, which means my other leg is, as she said, 15. And so my answer, without any calculations needed, is 15. And I'm done. Looking at number 6. My hypotenuse is x, so that's the one I'm finding. So I'm not going to look in my Pythagorean triples for the largest number. I'm going to look for the two smallest. I need to look for Pythagorean triple where I have 24 and 45. Do I see them? Yeah, here it is. And so the hypotenuse is? And so without any calculations required, I can say that this side measures 51. Looking at number 7. Number 7, very similar setup. I'm trying to find the measure of the hypotenuse. Here are the measures of my two legs. But as I look through my Pythagorean triples chart, I don't see 28 or 96 on the legs. So this could be a multiple of one that I already have. And I just don't have that multiple listed out. So I need to go and try to find this multiple. So here's how I'm going to do this. I'm going to take 28 and I'm going to put it in a fraction over 96. And I'm going to reduce this down as far as I can. And those two numbers then will become the two new numbers that I'm going to use to look into my chart. Okay, they are both even numbers, so I can divide them by 2, and I end up with 14 over 48. Okay, thank you. I still...
Yes.
Oh, I see it. There it is. Do you see it?
Yes.
It's right here. Which means this side is, it's related to 50. It's not actually 50, because how did we get to 14 and 48? We divided the original triangle length by 2. Which means to undo that division by 2, I need to undo division. Multiply. To go this way, I divided by 2. So if I want to go backwards, I need to multiply by 2. And so I'm going to take this value, I'm going to multiply it by 2, and my actual side length is 100. This is the trickiest part to Pythagorean triples, so that's why I want to make sure that you're feeling okay with this before we move on. So here are my two original side lengths of my triangles. I made them as a fraction just so that I could look at them. I noticed that I could reduce them both by 2. And then I looked into my chart and I noticed that I had a Pythagorean triple with 14 and 48. And it gave me the other side length at 50. But these measures are not 14 and 48. They're actually 28 and 96. And to get to there from the 14 and 48 that I have to multiply by 2. Which means I have to take this 50 and multiply it by 2 for the 100 that is my actual answer. Sort of? Kind of? Okay, cool. Let's do some practice with Pythagorean Theorem. We have 4 items for you. Pick the one that's the hardest for you. Number 4, because we've got craziness happening, right? All right, but remember we're looking at just the triangle, so we're looking at just this piece. Oh, hi. Highlighter, you died on me. No. Okay, let me cap it, see if it'll come back to life in a few minutes. So here's my hypotenuse. So that's C. One of my legs will be A. No one cares which one you pick. My other leg will be B. And then I can fill it into my formula from the Pythagorean theorem, which says a squared plus b squared equals c squared. Okay, substituting, a was 16, so 16 squared plus, I marked b as 33, so that's 33 squared, And that should equal c, which I was given as x, and that's squared. So please help me, I need 16 squared. Anyone with a calculator out? You have it? You don't have an app on your phone? Calculator app on your phone? No? You might want to think about downloading one. Most of them are free. You can even get a scientific one. You can get a TI-84. 256? As he interrupts my hashtag, this video is not sponsored by. 33 squared? 10 what? 1089. All right, and that equals x squared. All right, so I need to add those 256 plus 1089. $13.45. And that is the square of x, which is the length of my hypotenuse. And I want the length of my hypotenuse, so what should I do? I want to get rid of the square power, and so I need to take the square root of both sides. That means that x, my hypotenuse, is equal to the square root of 1,345. I cannot think through. Oh, okay, I'm going to try. Huh? Yes. And we need it in the exact value if possible. All right, so I need to find all the factor pairs of 1345. All right, here we go. I know it's divisible by 5, so help me out. 1345 divided by 5 is? 269. What's 269 divided by? 12. Is it divisible by 3? No, it gives you a decimal, right? Right? You do 269 divided by 3, decimal? Or fraction? Okay. I wonder if this number is divisible by 9. So check if check to see if it's divisible by 9. This thing divided by 9? No? Okay, now I'm just going through perfect squares because I don't know. What about 25? No? 16? We're guessing at this point. No. Okay, so we're going to say that this one doesn't have factors that are whole numbered square roots. So yeah, let's just give it a decimal, shall we? Maybe 1, 2 decimal places? 36.667. Did you need a copy of the notes you heard? They're right here on this table. I'm so sorry.
Well, because my computer hit it.
Oh, okay. All right, so that's it for that one, yeah?
Is that allowed?
Yeah, this is allowed. If you can't find the way to reduce this as the exact value, then this becomes your exact value, and then you give the approximate, and you're done. Awesome. So now that we have the Pythagorean theorem, you can use the converse of it to classify triangles when you don't have angle measures, which is the coolest thing, because up until now, if I said, what kind of triangle is it? And you said, it's acute, and I went, where are the angle measures? You know, you couldn't do it. But now we're going to have a way to be able to classify whether it's acute, right, or obtuse using just the side lengths. So we're going to start with the converse of the Pythagorean theorem. Pythagorean theorem says if it's a right triangle, then a squared plus b squared equals c squared. Then the sum of the squares of the short sides is equal to the sum of the square of the long sides. So when that sum is equal to then we have a right triangle. Nothing new and exciting. What gets nice and exciting is when we start putting in inequalities. If the square of the long side, okay, we're not talking hypotenuse anymore because we're not sure if this is a right triangle or not, but if we look at the side lengths and we grab the one that's the longest, if that value squared is less than the sum of the squares of the other two sides, the short sides, then our triangle is acute. Excuse me, I was about to sneeze. If we take the long side and we square it, and that value is greater than the sum of the squares of the other two sides, then it is an obtuse triangle. And that's going to be our test. We're going to do that a squared plus b squared, c squared, and then we're going to compare them. If they're equal, we say it's a right triangle. If they're not equal, we're going to look to see which one is bigger or smaller. If the long side squared is smaller, we call the triangle acute. If the long side squared is bigger, we call the triangle obtuse. Let's practice. Let's look at number 1. All right, which one is the long side? 50 because it's the biggest number. And then the other two sides is going to be A and B. No one cares what order you put them in. I like alphabetical. And I'm going to do what feels like the Pythagorean Theorem. A squared plus B squared. But this time, instead of saying equal to, I'm going to say I don't know. C squared. All right, 30 squared is 900. 40 squared is 1600. That has some relationship to the number 50 squared is 2500. All right, 900 plus 1600. What is that? 900 plus 1600. 2500. Because 9 plus 16 is 25, and then we have the 100. How are these two numbers related? They're equal, and because they're equal, this thing is a very good. And we're just going to write right triangle, and we're done with our classification. Let's look at number 4. Same setup. The biggest side is going to be our C. I'm going to color that into green for you. So there's the biggest number. The other two are going to be our A and our B, and it doesn't matter what order you put those in. 6 squared is 36. That plus 8 squared. What is 8 squared? 64. And that has some relation to 9 squared. 9 squared is 81. 36 plus 64 is 100. What's its relation to 81? It is greater than. Okay. Now you have to remember which way the theorems are written. The theorems are written as the biggest side squared is relationship. So if I read this, the biggest side, 81, is less than 100. So it's an acute triangle. Yeah, because it's written backwards from our theorem. Because the symbol looks like it says greater than, and if you read it left to right, it does, but we're going to read it right to left. Because our theorem says if the largest number squared is relationship to the sum of the squares of the other two sides, which is opposite of the way we wrote it here. All right, let's do number 2. So we have one more example so we can get that into our heads. Here's my biggest number. Here are my other two numbers, my other two sides. 20 squared, you told me earlier, was... Oh, you didn't tell me what 20 squared was. Okay, tell me now. What is 20 squared? 400. You...
Doesn't matter with A or B.
Correct. A and B doesn't matter. Just C has to be the big one. Some relation to 40 squared, which you told me was 1600. All right. 400 plus 900 is, 1200? 900, 1000, 1100, 1200, 1300. 1300 has some relationship to 1600. What is that relationship? Which one's bigger? Yeah, the 1600, the c squared, is bigger than 1300, the sum of the squares of the other two sides, which means this is a... Very good. And that's it. This is the most complicated part. That's all I had for you today.